Hello everyone, I am going to explain question number 1 from exercise 7.5 from class 12. So as you can see, the question first is find second order derivative. So we have to find out the second order derivative. The meaning of second order derivative is first we have to differentiate once and then again whatever answer will come, again we have to differentiate. Like we will solve the first A part, y is equal to x cube plus 10x. So we have to find out its second order derivative. So first I wrote here y, then since y is in terms of x, that's why I differentiate y with respect to x. So it will give you dy over dx, and here directly differentiate it. Now onwards you have to do in short. So x to the power 3, when you will differentiate, you are going to use the formula x to the power n. So the differentiation formula of x to the power n is n x n minus 1. So what is n here? N is 3. That's why 3x 3 minus 1. So that's why differentiation of x cube is 3x square. Now 10x differentiation is sec square x. So that is your, since its order is 1, that's why it's first order derivative. Now to find out the second order derivative, we will differentiate this again with respect to x. So when we differentiate dy over dx again with respect to x, it will convert to d square y upon dx square. So this is your second order derivative because its order is 2. Now here you have to differentiate again with respect to x. So when we differentiate, 3 will behave as coefficient, so 3 will come in front. X to the power 2 you have to differentiate, so just use n x n minus 1 formula, and this sec square x you have to differentiate. So first it will behave as x to the power n, that is n x n minus 1. Then according to the chain rule you have to differentiate sec x again. So sec x differentiation is sec x and 10x. So I hope it's clear to you. First we differentiated it by assuming it as x to the power n, that is n x n minus 1. Then according to the chain rule you have to differentiate sec x again. So when we differentiate sec x, because of chain rule, the answer will come sec x and 10x. So just simplify, you will get 6x only here, and when you will simplify you will get 2 sec square x 10x. So this is your second order derivative for A part. Now we will move to the B part. So B part of same question is y is equal to x square plus 3x plus 2. When we differentiate it with respect to x, we will get first order derivative, that is dy over dx. Here use xn formula, that is n x n minus 1, and the 3 will behave as coefficient and x differentiation is 1. Now since 2 is constant, so differentiation of 2 is 0. So when we simplify it, we get 2x plus 3. Now to get the second order derivative, again dy over dx we have to differentiate with respect to x. So its first order derivatives, if you differentiate it again with respect to x, it will convert to the second order derivative, that is d2y upon dx square. Now we have to differentiate this side also. So 2 is coefficient, so it as it is, x differentiation is 1 and 3 is constant, so 3's differentiation is 0. So answer is 2. So 2 is the second order derivative for B part. Now we move to the C part of same question. In C part you can see the function is y is equal to x cos x. So it is the product of two functions. So when we have to differentiate the product of two functions, the formula is first function as it is, differentiation of second function, plus second function as it is, then differentiation of first function. So when we will differentiate this with respect to x, here you will get first order derivative, that is dy over dx. First I kept x as it is, then cos x differentiation, then cos x as it is, then differentiation of x by using this formula. Now we will differentiate, and cos x differentiation is minus sin x, that's why here minus x sin x came, and x differentiation is 1. So cos multiplied by 1 is only cos x. So this is your first order derivative of given function. Now to get the second order derivative function, we have to differentiate it again with respect to x. So when we differentiate it with respect to x again, we will obtain the second order derivative, that is d2y upon dx square. And here again you have to use this formula, that is u dot v formula. First I kept x minus sign outside, then x as it is, differentiation of sin x, then sin x as it is and differentiation of x, and cos x take differentiation. Now in next step, this minus sign as it is here, sin x differentiation is cos x. So the answer of this term is x cos x. Now here differentiation of x is 1, that's why sin into 1 is sin only, then bracket close. Cos x differentiation is minus sin x, that's why plus change to minus, so minus sin x is the differentiation of cos x, that's why. Now open the bracket. When you will open the bracket, all term have minus sign, so take minus common, and this sin x and sin x will get add, so you will get 2 sin x. So this is your second order derivative for given function. Now we will move to the D part of the same question. In D part, see the question. Y is again in terms of x, so we will differentiate with respect to x. That will give you the first order derivative, that is dy over ds. 2 is coefficient, so 2 as it is. Sin x differentiation is cos x. Again here 3 is the coefficient, so 3 as it is. Cos x differentiation is minus sin x. Now to get the second order derivative, differentiate it again with respect to y, so it will change to the second order derivative. Cos x differentiation is minus sin x, that's why minus 2 sin x came, and sin x differentiation is cos x. Now both terms have minus sign, so take minus common. That's your second order derivative for given function. Now we'll move to the E part. In E part again, y is the product of two functions. Among them, the first function is e to the power minus x and second function is cos x. So we'll use this formula. So I kept first to differentiate it with respect to y. Here we obtain dy over dx, and here we use this formula. So first I kept e to the power minus x as it is and cos x differentiation, then cos x as it is and e to the power minus x differentiation. In between, because of formula, plus sign will come. Now cos x differentiation is minus sin x and e to the power minus x differentiation is minus e to the power minus x, because students, e to the power x differentiation is e to the power x only, but when we differentiate this minus x, because of the chain rule, we will get minus 1. That's why minus came in front. I hope it's clear. How we obtain this? First we have to differentiate it. So we will get e to the power minus x, and then again because of chain rule you have to differentiate this minus x, that will give you minus 1. So minus 1 multiplied by e to the power minus x is this. So this is your first order derivative. Now in this you can see minus e to the power minus x is common, so take it common, sin x and cos x as it is. So this is your first order derivative. To obtain the second order derivative, again differentiate this with respect to x. So we will obtain, here you just see this minus sign I kept outside with the big bracket. Then first, because it is in the form of u multiplied by v, means product of two functions. First function is e to the power minus x and second function is this bracket. So first I kept e to the power minus x as it is, then we have to differentiate this bracket. That's why derivative symbol entered in both the terms. And then I kept this bracket as it is, and then we have to differentiate e to the power minus x. So see the next step. This e to the power minus x as it is. When we differentiate sign, we will obtain cos, and cos differentiation is minus sin x. And here, when we differentiate e to the power minus x, we will obtain minus e to the power minus x, because e to the power x differentiation is same. But when we differentiate minus x, we will get minus sign again because of chain rule. That's why it came. Now this bracket as it is. Open the brackets, and here you can see that e to the power minus x is common, so take it common. And then just open the bracket. So you will find that cos and cos get cancelled and sin are having the same sign, so it will be minus 2 sin x. And finally open the bracket, that will give you plus 2 e to the power minus x sin x. Now we will move to the next part, that is last part of the question. So here y is a sin x minus b cos x. So since y is in terms of x, so we will differentiate it with respect to x. That will give you the first order derivative, that is dy over dx here. And in right hand side, a is the coefficient, so a will come front. Sin x differentiation is cos x, and then b is a coefficient, so b will come as it is. Cos x differentiation is minus sin x, and that because of minus sign, minus minus what? Positive here. and so this is your first order derivative. Now differentiate it again with respect to x, that will give you the second order derivative. Here d2y over dx square means second order derivative. So you have to differentiate it again with respect to x. A will come as it is, cos x differentiation is minus sin x, and sin x differentiation is cos x. So this is your second order derivative for the given function. So the first part of exercise 7.5 is completed. So in this exercise we are finding mainly the second order derivative. So it's very simple. First to find out the first order derivative, that is you just differentiate once, and then again whatever answer will come, again differentiate it, and take care of the formulas. Mainly three formulas are very important. That if two functions are in product, then use u dot v formula, and if the function is in fraction, then use the fraction formula, and always take care of the chain rule, that you should be careful that your derivative symbol should enter till innermost function, means you have to differentiate till innermost function by using the chain rule. Thank you.